Hi, Burb. Also, Kiwi is going to be keeping us company today because I'm home alone. Say hi, Kiwi. This guy. So if you hear any weird screaming in the background, it's probably him. Hi. How can I make this a little bigger? Huh, it's funny. Okay, here we go. So everyone can see my browser and everyone can hear me and you can't see anything else, right? Please tell me if I need to zoom in or on the browser or anything like that if you can't read, but hopefully there's enough bandwidth and the picture is coming through clear and everything is great. Interesting. So I've noticed always about 8 people end up actually joining on Sunday. I wonder what that's about. Cool. So we're gonna get started. Hi everyone. Thank you for joining on this beautiful Sunday. It's very sunny today in San Francisco. I don't know where is everyone at? What kind of time zones are you in? Please sound off in the chat room because one of the things that you have to keep in mind is we're not here in person. I can't actually see you. So you're gonna have to use the chat room a lot. I'm watching it. I might talk back. The way this is gonna work technically is I'm gonna ask you a lot of questions. We're gonna make it as participatory as we can. Smoky in Vancouver. We had a lot of smoke here as well. It's seems like the whole west of Northern America is kind of in flames right now. India, wow. How late is it in India, or is it already early? It's very far away. So the name of the game today is we're gonna go through everything together. I'm going to what I found works best is me doing things and asking you to help me out when coding things. I'm gonna ask you a lot of questions. You're gonna be talking in the chat room. We're gonna have a couple of exercises that you're gonna be doing on your own, and I'm just going to twiddle my thumbs here for a couple minutes. I'll try to make sure there isn't too much dead air because whereas dead air works really well when we're doing this workshop in person, it doesn't work that well on video because I don't have that direct feedback from you guys to see what you're doing and whether you're struggling. So please don't be shy about asking questions in the chat room. Don't be shy about asking me to open a breakout room and we can chat face to face or voice to voice at least to help you out a little bit. And yeah, basically this is going to be a fun 4 hours, I hope. We're going to be taking short breaks at the top of every hour. There's going to be a couple times I have to change the battery in my camera. There's not much I can do about that. It only lasts so long. And hopefully you already know kind of the basics of React, some ideas behind componentization, or you kind of understand declarative rendering, you're familiar with JSX and modern ES6. I will help you out if you have questions with any of those things. I'm trying to make this a very inclusive workshop, but in the interest of getting through all the material in 4 hours, we won't be able to go into extreme detail about every syntactical. If you're struggling with ES6 syntax, I have this cheat sheet that's free. You can go to es2017.io. It shows all the modern JavaScript syntax that you can look at in like, it uses code sandboxes, or I think CodePens. Old stuff on the left, new stuff on the right. So if you need to brush up on anything, you can do it there, or ask in the chat room and I'll explain it briefly. Today we're going to build a couple of data visualization components in a couple of different ways. We're going to animate some things, we're going to do black box integration, we're going to do full feature integration, and it's all going to be building up to a sort of dashboard of a single data set that uses a couple of different scatter plots that are connected together. We probably won't be able to finish the whole project. After giving this workshop twice. Oh shit. Okay, let me do something. I forgot to deploy the materials I updated this morning. Or rather, I deployed them, but I didn't rewire the domain. Just a second. So I think you can't see what I'm doing on the screen right now because you're looking at the browser, but I am just doing a quick deploy of some updates I made this morning. And of course, Yarn build is going to take a while because my computer is busy with lots of stuff going on. So how's everyone doing? Everyone feeling good? Enjoying your Sundays so far? Chat app is taking up my whole computer. I think there's a way to make the window smaller. I don't actually know how to do that, because right now I'm not. I think you can just resize the window. That might help. Otherwise, maybe you can pop out the chat. I don't actually know. It's a good question. That works as well, using it from the browser. I never thought of that. I've always used it from my computer. Actually, let me see if I can show you what I'm actually doing. Okay, so now you should be able to see my entire screen, and you can see that I'm actually just waiting for the production JavaScript bundles to build. And I may have actually done that before, but such is life. Maybe if I stop recording. Okay, so as I was saying, we're going to build components and our exercises are going to build towards this final project. But in this 4-hour version of the workshop, you won't have time to actually finish the entire project. So that's going to stay for you as homework if you're willing to do it. If you do your homework, I will be extremely happy. There's going to be a repository with my solution of the homework problem, and you can always email me and I'll help you out with any questions. But I have just experience has shown that in 4 hours it is impossible to get that entire thing done. It's more of an 8-hour format version. So I first have a question for you. What do engineering salaries, an 1854 cholera outbreak, and T-Rex have in common? Now, while you think about that, I'm going to you can try answering in the chat room. But while you think about that, I'm going to tell you that today the goal is we're going to answer the questions of why you would want to use data visualization, why you'd want to do it with React, why D3 is probably the best library for data visualization out there. We're going to talk about when you should or shouldn't use an existing library. We're going to look at some of the libraries that already exist out there for that you could potentially use. I'm going to teach you how to understand any D3 example that you find out there, any code, any D3 code, you should be able to understand it after this workshop. And we're going to look at a quick way to integrate D3 into your React projects. We're going to integrate them in a scalable, maintainable way. And we're going to build a simple animation with transitions, a simple animation with a game loop, and we're going to try to connect multiple charts to the same data, but probably we're going to fall short there. So to kind of whet your appetite, I'm going to show you a couple of things I've built over the years with React and D3, and these are not practical examples. They are just things that demo well, or at least I think they demo well, but they're mostly just there to show you what's possible. So one of my favorite ones is this animated typing example, where you can say hello world or hello workshop peeps, and the letters kind of fall down, and it's a great, they fall down, they also fly away when you're deleting stuff. You can go here and type. And the cool thing about this example is that transitions are done in D3, and it's a great example of declarative rendering where the main component is just rendering letters in a loop and doesn't have to care about anything, and each letter on its own worries about how it's going to transition in and out of your visualization or in and out of the demo. So that's kind of cool. Another one is an example of using canvas rendering, where I used the game loop approach for my collision detection is not that great, but this is using a game loop approach for animation, where a MobX store is recalculating the position of every marble on the screen with every tick of the animation. So 60 times per second, we recalculate positions, re-render, and the whole thing becomes an animation that's also interactive, and things are happening kind of in a cool way. And this is all rendered on canvas, so you have a lot of flexibility with how you render stuff. Another one is this example that shows how far we can push just React, and in this case Redux on its own, because, well, it doesn't work as well when I'm doing a bunch of things with my processor, but I was able to push this to smoothly animating 20,000 elements at the same time on a mobile phone. So I was using, I think, a iPhone 5 at the time, and it was still able to animate 20,000 particles in the browser, which I think is pretty cool. Another one is, let's say, this is also a pretty cool example. This shows, oh, this one is a video actually. So this is a visualization of my traveling expenses that is streaming data into the visualization just for kicks. But the main point is that these are two graphs that work together and are connected via React context. So when you hover over one of them, both of them kind of change, and they're both tied to the same data. What the idea here is that you can use the same data, feed it into a different data visualization component, and that component is able to completely declaratively do something different with the same data and the same inputs. What else? Yeah, so that's kind of a couple of examples to give you an idea of what's possible, of what you will be able to do when you're what you will be able to do after this workshop. And Has anyone guessed what engineering salaries, a cholera outbreak, and T-Rex have in common? Or you've probably just scrolled down in the that most people have only heard about how big they were. That's a good one. Um, Context is planet Earth. So actually, you the idea is that you can learn about them through data visualization. A while ago, I built a data visualization of software salaries using using a visa data set for H-1B visas, because that's a public data set. And I learned that software developers, software programmers, and software engineers have very different average salaries. And if you call yourself an engineer, you can make up to about $30,000 more per year than if you call yourself a developer. So that's a very important distinction to make. I don't know what difference it is in what you're actually doing. You're still writing code most of the day, but being an engineer is worth a lot more money than being a developer. So next time you're talking to somebody who's about to give you money, call yourself an engineer. And the cholera, John Snow. So in 1854, London had a huge problem with cholera, and back then nobody had any idea what causes cholera because they didn't know about germs yet. They thought maybe it's transferred to smog, maybe it's just something that's in the air. But John Snow plotted probably one of the first examples of a data visualization. He plotted every death from cholera on a map of London and realized that they're all kind of centered around this central area. And he was able to, through data visualization, he was able to prove that cholera is actually spread through polluted water, which back then was a very, very controversial statement. Like, drinking water can be polluted and cause disease? What? And this is probably one of the coolest examples I've ever seen of data visualization used on the internet. A group of researchers from, I think, AutoCAD, if you click on this, you'll find the actual source. They designed a data set, or a couple of different data sets that have the same summary statistics. So the same average values, the same correlation values, and I don't actually know what SD is, but point is that when you look at these data sets through summary statistics, they all have the same values, but when you visualize them, you see that they are very different, and one of them actually renders as a Datasaurus or a T-Rex. So that's what engineering salaries, cholera outbreaks, and the T-Rex have in common. If you visualize that data, you will learn more about it than if you just look at the data and try to analyze it without drawing it out. And that's what we're here today. So, as I mentioned earlier, this is going to be an interactive workshop. I would like you to ask questions, as many questions as you can. If anything is unclear, just ask. If I'm going too fast, ask in the chat. If I'm going too slow, tell me that I'm going too slow. If anything you want, just say it in the chat room and I will do my best to accommodate and to make this workshop better, because this, after all, is a workshop for you. I'm here because of you. You're here because you want to learn. So I have an important question, actually. Why are you here? And this might seem like a weird question, but I would like you to try answering in the chat room. Whatever is the first thing that pops to your mind when you ask yourself, why am I here? Why did I come to this workshop? Because answering that question, either just to yourself or publicly in the chat room, will help you focus. It's going to help you get out of this workshop what you want to get out of this workshop, because it's going to automatically prime your brain to look for those details that you care about. Whether it's solving a particular problem at work, whether it's just learning something new, whatever your reason for being here is, if you can sound it off in the chat room, that would be great. And I'm also using this to try to figure out how much delay there is between what I'm saying and what you're seeing. Let's see, who do we have to mute? Cool. Seeing more React in practice, trying to just get a refresh from the last session. Perfect. I like Henning's answer, wanting to make things, not just be an analyst. Although analyst sounds like a really cool job sometimes. I'm still trying to figure out who I have to mute, but my manage participants thing is not showing up. So please, whoever's making noise in the background, if you haven't muted yourself yet, do that. So Eric Lee wants to learn React with a context other than my day job. Yes. So that's one of my goals with doing DataViz, is showing you something more interesting than just a to-do app or a form or something boring like that. Tried D3 by yourself, had a lot of issues. I would love to hear specifically what those issues were. So you don't have to write it out in the chat room if it's long, but if you can send me an email with answering exactly what your problems with D3 were, that would be very helpful for the book I'm currently updating and making better, because React and D3, the book itself, started as, hey, people who know D3, here's how you learn React. And it's more and more morphed into, hey, people who kind of know React, here's how you learn D3, because, different things change how popular they are. So it's always a pain to get things to work the first time. Yep, I agree. So this workshop, the materials on reactd3workshop.com, have two set lists for day 1 and day 2. Excuse me. We're going to skip day 1 today. That's from a format of the workshop that was 2 days. You can refer to it later or whenever. It's a great way to build some basics in React and get used to React as such. Today we're going to focus on day 2, where we're going to go through an intro of D3, integrate D3 with React, and then we're going to do animations. And in the end, you have the starter repo and some helpful links to help you with doing your homework. So let us begin with an intro to D3. Who here has used D3 before? Raise your hands in the chat room, because I can't see you. So I think at least 1 or 2 of you have used D3 before. But I want to get a feel for how used everyone is to it, or kind of what you've... Basically, I want to get a feel for how used everyone here is to D3, so that I can shape this workshop better. Because, workshops go where the audience wants them to go. Maybe that was a stupid question to ask. So, D3 is probably, like I mentioned before, D3 is the best library for building data visualizations out there. It's used by everyone from the New York Times to the Guardian. I need to sit back more so you can see when I'm doing stuff with my hands. So it's used by everyone from the Guardian to New York Times. It's an open source project that's actually got almost as many stars on GitHub as React does. So I think React is at just over 100,000 stars. D3 is at about 78,000 or almost 80,000 now. So it's a much more popular library than most people realize. And what I really like about it is just how flexible it is and how easy it is to build all sorts of different things with D3. Here's an example of a search result I had when I searched for D3 on Google, and it's just used for a mind-boggling variety of data visualization out there, and pretty much I can almost guarantee you that almost any visualization you've seen on the internet was built with D3 or using a library that's built on top of D3. But D3 has a little problem. It's not very easy to read. and it's just generally not. D3 code is often not very maintainable. It's kind of hard to use, and especially the way most people try to learn D3 is find an example on the internet, try to understand it, but mostly end up just copy pasting bits and pieces, and modify them until something looks the way they kind of want it to look. Who here has built a data visualization by copy pasting other people's example code before? Raise your hands. And I will wait for you to raise your hands in the chat room. Seem to be having a lot of delay today, or nobody wants to raise their hand. My access code is about it. Okay, cool. So very different audience today than we had last time. Last time everyone was like, yeah, I've done D3, I've copy pasted examples. So a lot of people, when they approach data visualization and when they're learning D3, use a lot of copy paste. And 5 hands raised. I don't see any hands raised. Maybe my chat room is being buggy. But anyway, or Ivan is making a hand, a joke. So if you look at D3 code out there that you find in most normal examples, it's usually done not with the idea of being maintainable code. Usually people build it as like, oh hey, I have this idea, I'm going to make some art, or I'm going to make this one visualization, put it out there and be happy. Most of it is done as one-off code, so a lot of it is just kind of hard to understand. It's very hard to learn from. A lot of one-letter variables, kind of spaghetti code, and D3 as such isn't really conducive to not writing spaghetti code. For example, this here is a bar chart. I don't know about you, but when I look at this, it doesn't really scream bar chart at me. It's even though I've been doing D3 for many years now, and I would say that I'm fairly familiar with how it works. Looking at this, I still can't really tell what's going on without reading everything in great detail, going line by line and saying, okay, this is doing that, then this happens, then that happens. It's kind of painful, right? Because we spend, the statistic I read somewhere is that we spend about 90% of our time reading code and only 10% of the time writing it. Probably kind of varies between whether it's a vanilla greenfield project, or you're doing something that you've been working on for a long time. But the longer you work on a project, the more time you spend reading code instead of writing code. So it makes sense to optimize your coding experience for reading, not for writing code. Although honestly, this doesn't seem that easy to write either. It's just a lot of typing for not a lot of benefit. So I want to help you understand this type of code using 3 key insights. Three key insights that will help you understand this code. The first thing you have to understand is that D3 code is always split into 2 different areas. The first is data manipulation, and the second area is DOM manipulation. So if we look at that same code from before, this magical D3 blob, it's actually rendering this sort of bar chart, or, well, something very, it is actually the same code. So this bar chart comes straight from the D3 documentation on how to build a bar chart. When you mouse over a bar, it colors red, and it's nice and simple. Everything is labeled, has nice axes, and it works pretty great. And it takes just about 43 lines of this soupy code that is very difficult to understand and doesn't scream bar chart at you. but there are actually two parts inside this code that you can look at, and kind of they help you piece apart or tear apart what's actually happening. First, you have data manipulation. This is where we prepare our variables, load our data sets. How high do I have to be doing? What if I move the camera down a little bit? Will that make it easier? Yay, now you can see my hands when I'm doing stuff, but my forehead is getting cut off almost. Okay, perfect. So this is where we're preparing our variables, setting up our D3 scales, which we're going to talk about in a bit, loading our data sets, parsing them, and so on. So the first thing that Mike Bostock did in this example was to set up some margins, which help him space things out on his graph. Then he calculates the width and height of that he has available to draw his thing. Defines two D3 scales, which will help him translate between data and positions on the screen. And in this d3.tsv blah blah blah, here he's loading his data set, setting up the domains on his scales. We're going to talk about that in a bit, no worries. And all the way down here where he's actually using the code that he's set up to calculate positions on to calculate from his data set to actual properties that he's putting in the DOM. So that's the data manipulation part. Throughout the day, we're always going to keep data manipulation in D3 because D3 is really, really good at this stuff. It's probably one of the easiest, quickest things I've ever seen for just manipulating data and turning it into different data. And then we have the DOM manipulation part. This is where we use D3, or where people often use D3 to actually construct the DOM that renders in the browser. This is very similar to if you were using React without JSX, it would look very similar, or if you were trying to do something with pure jQuery, it would also look pretty similar to this. So he starts by selecting the SVG element, and D3 selects, if you've ever worked with jQuery, raise your hand if you've worked with jQuery before. D3 selects are pretty much, oh hey, I just saw that feature. Even Maxim raised his hand. Wow, I had no idea that feature existed. Awesome. That's where the 5 hands were from. So D3.select is the same as doing $sign and then writing a CSS selector to select a direct reference to your DOM node. He then uses this SVG to append a grouping element, which is similar to, in SVG land, a grouping element is pretty much the same as a div, except it comes with a lot fewer defaults. It's kind of just helps you group things together and work with them in a group to move them around or whatever. He adds a transform, which is like an attribute that moves a group to whatever position you set, and then he's appending another grouping element to render an axis inside. So D3 axis bottom renders an axis. Another grouping element renders an axis on the left side, and then he does what is probably the most confusing part of D3, which is binding data to the DOM and using the enter exit update lifecycle to keep everything up to date. So basically what's happening here is g.selectAll takes the grouping element and selects every .bar element inside every rectangle with a bar class inside that group. None of them exist yet, but he's binding data to them and then using .enter to append a new rectangle for every new data point that's entering into the visualization. You can think of this as basically saying, here's my data, loop over it. And D3 uses this daisy chaining semantics to make that happen. And it's kind of confusing, but once you start thinking about it as just loops that are going through data, it becomes a lot easier. And we're not going to be using this, but it's important for you to be aware of it and kind of understand how it works, because it's going to help you in the future when you're looking for examples of D3 code and trying to translate it to React. But all of this, everything that you see here that's colored yellow right now, we're going to be doing that with React. So does this make sense to everyone? Actually, let's see if it makes sense. Let's try opening a random D3 example, and you guys are gonna tell me what's DOM manipulation and what's data manipulation, just to make sure that we all have a good feel for this. Let's see, what's a good example? Maybe this one is potentially good. Stacked to group bars. This is gonna have a nice transition. So grouped, stacked. So that's pretty cool. It looks like a nice transition and D3 magic. Now let's look at the code for that. Whoa, that's a lot of very soupy code. But let's go through it very quickly, and you're gonna tell me what's DOM manipulation and what's data manipulation. So I'm going to select this code. What is this, DOM manipulation or data manipulation? Data. Data, yeah, perfect. So all of this is data. He's literally generating random data here actually, and then using a stack layout. We're going to talk about layouts in a little bit to group things together. Now, what is this part? DOM, yep, perfect, cool. And if we look at, let's say, this part, data, yeah, wonderful. And now what is he doing here? Okay, so this is actually, yeah, that's plotting. So this is a mix of data manipulation and DOM manipulation. So the first part here is purely DOM manipulation. He's selecting all the rectangles and binding data to them. And then when he's defining all of the attributes, he's using the data setup from before to define values for those attributes that he's putting into the DOM. But it's mostly DOM manipulation. Cool. So you now have a feel for going into any D3 example. You're able to say, okay, these are the parts that I need to rebuild in React, and these are the parts that I can keep the same. And we're gonna see how that works later. Another very important part of D3 that you'll often see are D3 scales. So D3 scales are what I would say probably the most useful part of the D3 API ever. That's a weird way of saying it, but I really like D3 scales, and you'll see them a lot in pretty much every example out there. The idea behind scales is pretty simple, but the result is very powerful. They're essentially a function that maps a domain to a range. So it's some sort of transformation that takes an input data set and calculates the output data set. So if we look at a couple of examples in Code Sandbox, you'll see what I mean. Let's see, it loads. How busy is my computer right now? Not too bad. I think my computer's lying. There we go. So the recording software is currently taking 370% of my processor. Do I need to zoom this in? How well can you see the code? Okay, maybe 1 or 2 levels. Let's do that. Is that better? Perfect. Problem with zooming in is that if I zoom in too far, it's going to mess up the layout and it's going to actually make it harder for us to see what's going on. So here we have two different scales. We have an ordinal scale and a linear scale. Ordinal scales are perhaps the simplest scales because they directly map from a domain to a range. So triangles are red, rectangles are orange, polygons are green, squares are red. This returns a function that we use here. So if we say shapes of triangle, it outputs red. If we say shapes of polygon, it's going to output green. And that's the simplest transformation. It's basically like, you can think of it as a hash map or even a dictionary. It's mapping keys directly to their values. A more interesting one, and this one is used a lot, mostly for translating between data values and positions on the screen, so pixel values, is a linear scale. This is like a linear function that you learned about in, I don't know, middle school or high school. Y equals kx plus n. So we have a linear scale that maps a domain that goes from 0 to 200 to a range that goes from 10 to 500. So what that means is that if we call linear of 0, we're going to get 10 because that's the beginning of the domain maps to the beginning of the range. If we call linear of 200, which is the top of the domain, it returns the top of the range, so 500. And the cool thing about linear scales and also logarithmic scales and a bunch of other scales is that they do interpolation of everything in between. So if we call linear of 100, it returns a value that is exactly in the middle of our range. So the middle of 10 to 500 is apparently 255. If I call this with, let's say, 150, it turns to 377.5. I can even go above the domain, and it tries to figure out how the linear function behaves. So even though we called it with something that's above the domain, it still said, okay, that's probably 745. And another cool one that I don't think I showed last week is that we can change our domains. We can make our linear scales be I think the mathematical term is a convolution of different functions. So we can say that it maps from range 10 to 500 and 500 to 5000. And let's see if that worked. Maybe we have to change it here. So now it's able to say, if we call to 250, it finds something that's in the middle between 500 and 5000, which is 2750. But the beginning of the domain still acts as if the previous scale was there. So that's kind of how you can use D3 scales. You will see we're going to use them a lot for translating primarily data to pixels on the screen. But the general idea is that these are helpful functions that let you just map any domain to any range. What if domain and range have different sizes in ordinal? I don't actually know, but let's try. What's another shape that we can pentagon? So let's see what happens if we call shape of pentagon. It's still red. So I believe that ordinal scales end up anything that's beyond the range, they maps to the last value. Or let's see if that's actually true. So it actually starts looping. So triangle is red, rectangle is orange, polygon is green, square is red, pentagon is red again, and hexagon is orange again. So it reuses the range in a loop. I think there's probably additional functions we can use to change how exactly this behaves, but all of that is best I try not to learn this stuff by heart. It's better to know that it exists and then experiment or go to the D3 documentation to find out any details that you need. And the last really cool thing about D3 are D3 layouts. These are, you can think of these as pre-built calculations that let you calculate, that let you basically turn your data set into something cool that does everything for you. So we have, for example, a force layout, which takes a data set and calculates everything you need to draw a force-directed graph. Or you have a packing layout, a circle pack layout that takes data points and packs them into circles. There's a lot of these layouts out there. I don't actually know how many there are now. People keep developing new ones. I think the core library has maybe between 5 and 10 of them. But the main insight you need to know about the layouts is that they are data manipulation. They don't actually render any of this. They just give you all of the information that you need to render something like this. So even something like a pie chart is actually a D3 layout, because you call d3.py, give it a bunch of data, and it turns that data into an object that tells you these are all your slices. They have to go from this start angle to this end angle, and they have to be this big and whatnot. It calculates everything for you, so then you can just focus on drawing. So that's the inside of D3 layouts, for example, or like this force simulation is basically saying, okay, we're gonna, I forgot how this works actually. That's funny. But the idea is that the main point I'm trying to make here is that D3 layouts are just calculations. They transform your data set into a bunch of coordinates that you can use to do the rendering, but you are always in control of the rendering. D3 as such is never rendering anything. You are always doing that. So that gives you a lot of responsibility, but it also gives you a lot of power so that you can build whatever you want. So those are the three key insights. Code is usually split into DOM and data manipulation. Scales are great, and you're gonna see them used a lot, and you are always in control of the rendering. A few more cool things that D3 can do for you are maps. It comes with a lot of pre-built functions to just take geospatial data and turn it into a map, and again, it's just calculating positions for you. You still have to feed that into your rendering engine yourself and render it. It's got really good support for axes, and I'm gonna go close the door because the bird is probably being very loud in the background right now. That's better. So we're going to be talking about scales a little more later because they're a great example for black box rendering. D3 also comes with a bunch of different shapes. Like I already mentioned, it can do pie charts, it can do line charts, area charts, it can even calculate curves between different points and all sorts of really cool things like that. It has great support for transitions. You can also build custom transitions, so you can define if you've ever used tweening, I think that was very popular in the Flash days. Whoa. We're gonna talk about transitions later, but it's basically saying I want to change this attribute to this value, and I want it to take this much time. And D3 is able to magically figure out how to do that, even if you're talking about transitioning colors. D3 can transition colors, and that's just cool. So that's kind of what was I gonna say? That's kind of the basics of D3. Does anyone have questions right now before we move on to starting to integrate D3 and React together? Perfect. So that was a very quick introduction. Now let's see, it's 5 minutes before the full hour. Let's take before. Okay, so how is transition compared to CSS transition? The main difference is that when you're using D3 transitions, your transitions are running in JavaScript, which means you have a little more control over how it's happening, and you can also, I'll show you later, you can chain different transitions, so something transitions and then transitions to something else, or you can run multiple transitions in parallel and stuff like that. But the downside is that they are not GPU optimized, they're still running in JavaScript, so if you have performance issues and you can get away with using CSS transitions, it's often better to use CSS because that has GPU support and uses fewer resources, but means you have less control. The syntax itself is pretty different, but not that different, I guess. So let's take a 3-minute break. I'm gonna go grab some more water. You can stretch, limber up, because the next section is going to be a little more involved. We're gonna start coding together. You'll be able to code either with me in Code Sandbox, or you can do it separately on your own machines if you prefer that. I like doing it in Code Sandbox because it means I don't have to leave my browser and it's very easy to do everything there. You might hear a fire engine go by a couple of times because there is a fire station half a block down from my apartment, and they use this as their main route to and from the thing, unfortunately. And I've noticed that firemen, even when they're not in a hurry, they like flashing the lights and making a lot of noise. Probably just makes their life easier. So 3-minute break, then we'll continue with integrating D3 with React, doing some code together and learning a lot more cool stuff. GPU, and I think Uber has been working on a library, or at least I know a lot of Uber's internal data visualization uses WebGL so that they can get this GPU acceleration with large data sets. I haven't really explored that as much yet as I'd like, but I know that that's one way to get GPU support in your D3 stuff. Okay, so let's look at why you would want to use React together with D3. I already mentioned that D3 on its own has some issues, primarily when it comes to readability, maintainability, and things of that nature. So React, I believe, can really help you there, because React is built primarily to give you declarative. Because React primarily is designed to give you declarative rendering, which means that you don't have to worry about the enter, update, exit lifecycle that you have to worry about with D3. You can just say, here's my stuff, render it, and then you change your stuff and say render it again, and React kind of just figures it out. So for example, you have this animated alphabet where each letter is transitioning on its own. It's coming down when it's new to the visualization, it's falling down when it's leaving the visualization, and it's kind of moving left and right when it has more room to move left and right. So when letters before it vanish, it moves, stuff like that. So it's doing a lot of transitioning, but the actual code to render all of those is a normal loop. It says take all of the letters, map through them, and for each letter that you see, return a letter component. Then it has an interval that every second and a half just reshuffles those letters and says, here's a new set of letters. And React is really great at doing that tree diffing and figuring out where the differences are in your DOM and re-rendering things. And then we can use some transitions and React transition group and stuff like that to say to add animations to those things. So each letter on its own is taking care of the transitions, and your main component, the one that you're working on, that's the consumer of the letter component, doesn't have to worry about any of that. And that's really cool. That's like a very neat benefit of componentization, of declarative rendering. A great benefit of components is that your data visualizations become a lot more reusable and also a lot more readable. So here I was playing around with 4 different views of the same software salary dataset. I was filtering by all, by engineer, by programmer, and by developer. So I needed 4 different histograms. With D3, that would be kind of annoying. I would have to either copy paste a bunch of code or make a function that kind of does the histogram and does all those things. It kind of gets really muddied. But with React, I was able to build a histogram component and paste it 4 different times with slightly different data. And the cool thing here is that even if you don't know what you're doing, even if you're a complete beginner, if you can read HTML, you can look at this and say, oh yeah, this totally has some sort of element. I don't know what the G element is, but I don't know, it's there. It contains 4 different histograms, right? 1, 2, 3, 4. I can look at this, I can read it. And the important part here is that you as the React and D3 expert on the team, it's your job to make your code as easy to read for everyone on your team as possible, because when you have because the more varied the experience level of your team is, the more important it becomes that your code is really easy to read. Because when you have juniors or beginners who come work with your code base, if your code is really difficult to understand, they are going to mess it up. I promise you that. They're going to come in, they're not going to understand what's going on, they're going to have a difficult time following your idioms and principles, so they're going to make everything kind of messy, and then you're going to come in and you're going to be annoyed and upset with them. And it's so much easier if everyone can read the code, because here you can render a histogram, you know exactly what you have to do with it to make it render, and you don't have to know any of the details of how a histogram works or how to render a histogram, because you have a component and you can place it anywhere on the screen. And the end result is that you basically don't have spaghetti code anymore. Because if you compare, let's say that a histogram is very similar to a bar chart. If you compare this code that says this is a histogram to this code from earlier that doesn't even mention the word bar chart. Oops, I went back too many times. If you compare that to this code that never even says bar chart, where is it? I don't know. I find the components version to be a lot easier to read. Would you agree? Or rather, tell me in the chat if you disagree that the Feel free to say that components are stupid and that you prefer this code, but then I'm honestly not quite sure why you're at this workshop. Maybe that was a mean thing to say. Anyway, the idea is that if you're using components, you can neatly package up your code so that it's easy to reuse, easy to put in different contexts, and eventually you will build a data visualization library for your team specifically. So the end goal of what we're trying to learn today is that you are able to come into your team and say, we're going to build a library that is specific to our use cases, that solves our problems the way that we like them to be solved, and this is how you should do it. These are all the components, assemble them, do stuff with them, have fun, and it's going to work perfectly for you and your team. So before we get to that, you should always evaluate whether it's better for you to use a library that already exists or to build a library that's specific to your use case. The reason is that a lot of the times people come to me and say, hey, how do I build this chart in D3? Or I'm building some simple charts and I want to use React in D3. How do I do that? And my answer is always, don't do that. If you're building something that is a simple chart, just use Excel or use Google Docs. I promise you they are much easier and much faster for building a single simple chart than doing it yourself. It ever will be, because you're just putting in data and saying make a chart. So that's the easiest approach. It's not going to be scalable, it's not going to be dynamic, you can't host it online, but it's very easy. If you just need a chart, use a spreadsheet program. That's what they're designed for. If you do need some sort of dynamic charting that you host on the internet, you are still often better off using a library that already exists, because a lot of work has already gone into them. They have different trade-offs and different ways of doing things, but it's often going to be faster to use somebody else's bar chart component than it is to build your own. The main reason why you would want to go build your own, or rather, we'll get to that next, but the way you choose a library depends primarily on finding a library that's as close to what you're trying to build as you can find, because libraries often don't let you do stuff the custom way. They very quickly get into your way as soon as you get off the well-beaten path, off of how the library author envisioned this should be used. If you have to change it, you are in for a world of pain. So it's better to find a library that's already very similar to what you're actually trying to build. So that's why we're going to look at a couple of different libraries, and I'm going to talk about how easy they are to use. And this is going to be kind of an overview so that you get an idea of what's out there, and so that you can go into building your own stuff with your eyes wide open, and you don't come haunt me on Twitter 6 months from now saying, hey, you told me to build this stuff myself from scratch, and now I'm suffering and it's too much work and all I wanted was simple charts. So no, don't do that. Listen to what I'm about to say next. So Victory.js is a really cool charting library built by Formidable Labs. They're promising a bunch of data visualization primitives, and I built a very simple bar chart using some random data. It was pretty easy to build. Let's look at just the code. So you say victory chart component, you put in a victory bar, give it your data, and tell it how to access the X and Y parts of your data set, and it renders a bar chart. Come on, render a bar chart. You can do it. So you'll see this a lot today, unfortunately, where my computer is just struggling with the CPU. I don't know yet how to solve that, but for now you're just gonna have to deal with my code sandbox being a little slow sometimes. So it renders a bar chart, automatically adds axes, and it's even responsive, so it becomes nice and big when you give it more space. My favorite part about the Victory library is that when you're just putting in a chart that doesn't have any data, it will render something with using a fake data set that it comes up with on its own, which makes it really easy to see what kind of component you're using and how your data is going to look afterwards, so you can think, oh, this isn't actually the right component to use before you even plug in your data, or before you invest too much time. It's automatically going to show you, hey, this is what it's going to look like. Is this really what you want? And I like that. Another popular one is Recharts, which last I checked was still in beta. It might be version 1 by now. The nice thing about Recharts is that it's still pretty easy to use, much like Victory, and everything is animated. So if you like these sort of animations where data shows up and the charts kind of grow from their axes, Recharts is a great library for you. Unfortunately, if you don't want those animations, it's going to be really difficult to use, because when I was exploring it, I couldn't find any way to disable those animations, which is kind of worrying. But okay, they decided that this sort of animation is a cornerstone of a good data visualization library, so they put it everywhere. And it's still pretty easy to use. You say, I want a bar chart, I want an x-axis, I want a y-axis, and I want to render bars for every data that's in here. Pretty cool, easy to use, creates a bar chart. Nevo is probably the flashiest library I've ever seen. It has the most bells and whistles implemented by default of any library that I've ever seen for data visualization. You see, you have these nice axes in the background. Everything has a tooltip, renders labels right on top of the bars, and all sorts of cool stuff. It's actually really easy to use. You say, I want a responsive bar, and you give it data, your how it can access keys, and what the index is, and it creates the entire thing. What I didn't like about Nevo is that all of these bells and whistles, if you don't want them, are kind of difficult to disable, and the documentation was very involved. Rather, it was very detailed, very good at showing off all of the different features and components and bells and whistles and the entire kitchen sink that's there. But it was very hard to figure out how to actually use it, because it uses dynamic examples. You can play with them, you can change them, but just disabling stuff and taking things away was very difficult. So Nevo, if you want really complex, really cool stuff, easily done, perfect. If you want simple stuff, Nevo is not the right library for you. And probably my favorite React and D3 library is VX, because I think the guy who works on it is currently working at Airbnb, and Airbnb is using it for a lot of their internal data visualizations. And it's probably the most flexible library I've ever seen. It uses a lot of the same concepts that we're gonna be learning about today. It keeps D3 as the data engine. It keeps React as the rendering engine, and it still requires you to actually know D3. I have not actually used Plotly before, but I don't think I've ever heard of Plotly before. Is that a library, or it sounds more like it would be a service? So, but let me finish about VX. VX still requires you to know about D3 scales. You're still defining all of that on your own, and the cool thing is that you're still in control. You have a lot of control with VX. You loop over the data and you render a bar for every data set, and you kind of have to know what you're doing. So it's harder to use than the other libraries I showed you, but it gives you the most power. And probably I would say that after everything we learn in today's workshop, VX is a great starting point for building your own library if that's what you're interested in. And if you don't want to do it completely from scratch, if you want to start like halfway between from scratch and having a library, VX is a great idea. But let's see, Plotly. Oh, that's cool. Okay, so I haven't used Plotly before, but it also looks like a pretty good starting point. React Create Element. Is this an old library? They're not even using JSX in their examples. Or at least not in this example. Strange. Anyway, you should use, like I was saying before, you should definitely use a library if you find a library that meets your needs and that works the way you want it. Use a library. But where libraries often start breaking Where libraries often start breaking down is when you want to start doing something custom. As soon as you have to get off the beaten path of what the library envisions, you will often start struggling and you will start fighting the library. You might have to. It's honestly, a lot of the time it becomes harder to do something custom with using a library than without using a library. And the main consideration is, I have here like 4 different axes where how you can evaluate whether to use a library or not to use a library, but it boils down to this: the more long-term your investment is, the more you're trying to build something that's core to your business or to your problem. If you want to build charts or data visualizations, you should go more custom. If you need to just do a quick one-off, use a library. If you don't really care that much about long-term quality or maintainability, you can use a library or build it yourself depending on what you prefer. Scope is also very important. Again, is this a one-off or are you building a very complicated custom data visualization? The more custom and long-term you're trying to build your thing, the more you should use an actual approach of building your own library, because that's going to help you iterate and evolve over the longer period of time. So, how do you build your own? We're going to start with a very simple overview of how you would build a rectangle using SVG, using pure SVG, using React with SVG, and so on. So who here has used SVG before and is kind of familiar with the basic principles of SVG? Raise your hand. Ivan raised his hand. Perfect. Interesting. Okay, so SVG is short for Scalable Vector Graphics. It's an image format that uses XML to describe shapes on the screen, which makes it easy to use with JSX and with React in general. And it also means that we can transfer pure text to our browsers and to our users, and they will render things on their own. Downside of using SVG is that it's not GPU accelerated, so if you have a lot of elements on the screen, SVG will start suffering from some performance issues. But that's really when you get into thousands and tens of thousands of elements. That's when really problems begin. There's various strategies for how you can resolve that, but those are more important. We're not going to get into those today, unfortunately. So a simple rectangle in SVG takes an SVG element, and inside we render a rectangle with a width of 200, a width of 100, height of 200, at position 50 and 20. With SVG, we can take that same thing, and we're returning a rectangle element from our React component, and that renders as a rectangle. If you wanted to do the same thing in D3, it would take quite a lot of pretty spaghetti code, which I personally don't like. It means you have to append the rectangle, set every attribute separately, and it's just a pain in the ass that is much easier solved with React. So, excuse me, my nose is itchy because I had a cold all week. So, as I mentioned, I think a couple times already, the basic idea we're going to be learning today is that React is going to own the DOM and D3 is going to calculate properties. The main problem we're going to run into with that is that D3 likes to control the DOM, in some cases at least, and D3 objects have a lot of internal state, whereas React wants everything to be stateless and driven by props and everything to be driven by props. So we're going to be spending some time consolidating those two facts. D3's internal preponderance, preference for D3's preference for internal state versus React's preference for having components that are driven purely through props. You've probably heard of the idea of controlled and uncontrolled components before. We're going to try to make most of our components controlled components, which means they are a pure representation of their props, even though the D3 objects that they're using have internal state. Does that kind of make sense? Sort of. Perfect. So it's okay if it only sort of makes sense right now, because we're going to be talking about it for the next 2.5 hours. So we have plenty of time to go from sort of makes sense to yes, totally get it, wonderful, and so on. So the first approach we're going to use for integrating D3 and React is also the simplest approach. It's what I call the black box approach, where we can take, and I'll show you how this works. We can take any random example of D3 code from the internet, wrap it in a React component, and put it in our React project. This is useful particularly, I like to use the example of axes, because axes are incredibly frustrating to build on your own, because they have a lot of small moving pieces, a lot of tiny little details that you have to get just right for the axis to be really useful and great. And D3 already has magnificent functions for generating axes, so you don't want to be rebuilding those on your own. And it's also great for when you want to just very quickly sketch out some idea, or you find an already existing D3 example that you just want to put in your React project and not worry about. All of those are things where the black box approach works great. So here we have a quick example of just D3 code. This is pure D3 code that renders an axis. We create a scale that maps a domain. Let's open this on Code Sandbox so I can show you how these things affect each other. Okay, so that's interesting. Why is it talking about a diff? Looks like it realized I was making some changes to this in the last workshop and saved them in my local storage. That's actually very neat. So let's Command Z out of this. Can I? No. So I think it was at 0.10 and 0.200. So we now have the same code again as in the embed. We start our axis by defining a scale. This is a linear scale that goes from 0 to 10 and renders as 0 to 200 pixels wide. And our axis function is defined as bottom, and it takes our scale to know how to size itself. And we render it by selecting the SVG element, appending a grouping element, translating that to a specific position on the screen, and calling axis. That puts in a bunch of little SVG code, and I'll show you why it's so annoying to build. If you were going to build axes from scratch, what you would have to deal with. So I zoom this guy in. I think it's a little slow, but let's see. So we have this SVG element that renders a grouping element that has a path for the main line, and then a bunch of little grouping elements for each tick of the axis. Each tick has a line and some text. So that's how an axis is constructed. Now the cool thing here is that if we change the domain to go from 0 to 20, the axis automatically changes, and you can see that D3 axes are smart enough to figure out their labeling so that they don't get overwhelming. If we change this to 200, you'll see that each one starts jumping by 20. So there's always exactly 10 ticks, and they automatically adapt to what our data is saying. We can also make it go wider by changing this to 300, and that's going to stretch it out. My SVG apparently isn't big enough for that, but we can also make it narrower and all sorts of different things. We can make the axis go on top like that. We can say it's to the left, so it renders there, or to the right, so it's flipping to the other side. All sorts of different things. And one very important SVG property that we're going to be using a lot is the transform attribute, which we're going to mostly be using with translate. I changed it to left. We want it to be bottom. So we have the translate 1030, which means take this grouping element and move it by a vector of 1030. So 10 to the right and 30 to the towards the bottom. So if we change that, it changes the positioning. So why exactly 10 ticks? Because, you know, that's a good point. I think it figures out that 10 ticks fall nicely on the thing. So if we change it, maybe it's always trying to do 10. We can also change how many ticks we want by saying ticks 20. No? I know that there used to be a function, so you can specify how many ticks you want with a function called it. I can't remember off the top of my mind, but I guess 10 is just the default. If you have dates, let's see, can we have dates? New date 2018. Let's say, what date is it today? August 26th, so date 8/26, and we want to go to new date with, let's say, my birthday, 2018, 10/25, and it's not able to figure it out, unfortunately. So there are I know that there are scales that are specifically designed for time. I can't remember them right now, but you can do that. So you can make it be something other than a number. You can also specify custom functions to render ticks. So let's see, I think it's tick format. Let's see. Will that work? Tick format. No. Oh, that's what I did wrong. So now everyone says hi, but we can also change it to be d.iso. Yeah, so you don't set the ticks where you have .call, but you set them on the actual axis. The thing I was doing wrong was trying to set them on the scale. You have to set them on the axis. So how do we format the, let's say, d.getYear? So that should work. No? Damn, now I can't remember how do you format a date in JavaScript? So this is basically, if you call tick format, you can define how you want your ticks to show up, and I think we can here say that we want only 3 of them, and that should work. Yeah, so that's working, but because they're dates, they transform into numbers, into milliseconds from the Unix epoch, so they're rendering weirdly. We would have to remember how to format a date here, but I am having trouble. Well, I can look that up and get it back to you, but basically it does work even if your input is time, and it's able to figure it out. Let me Command Z out of all of that so that I make sure I'm not changing the thing. Okay, so that's the basic D3 axis. Now if we want to put that into React, we're going to be using battery down. Okay, I'm back. So to put this in a to put our axis in a React context so that we can render it as a component, we're going to use something called we're going to use lifecycle methods or lifecycle hooks to hook into the React lifecycle, and we're going to give rendering control to D3 for a little bit. Make sure that, or essentially not for a little bit, we're just going to take a React component, give rendering control to D3, and let D3 render everything in our element, and that's where the black box part comes from, because once we give up control from React to D3, React is no longer able to help us with diffing, with speed optimizations, and with everything that React does for us, which it basically makes our component a black box to React, and that's where the name comes from. So here we have a rendering of two axes at vertical position 10, and the reason it looks like one axis is because I'm not doing anything with this property or with this prop, and we're going to look at that next. So an axis component uses it's created as a class-based component because we need refs. It starts by defining by creating a React ref. Does anyone know what React refs are? You can answer in the chat room. If you've heard of refs before, track an actual DOM node, yeah. So React refs let us have a reference. They allow us to have a reference directly to a specific DOM node as it shows up in the browser. So we create a React ref, and when we're rendering, we render a group element which is going to act as our anchor element, and we give it a ref of this.gref. And what do I have to change here to actually listen to the Y prop and render these two axes so that they're not overlapping? Can anyone take a guess? And I know I haven't explained yet what everything that's happening here, but I think you know the answer to this one. Nope. It's not making two refs, but it is actually listening to the Y prop. So here you can see I'm passing in Y as a prop. I'm doing it the same both times, but I can change it. So in the axis component, I can take the ref out of my props, and I can use it in the translate transformation like that. And now there are two axes because it's actually listening to its vertical positioning from the props. Why do I need braces around the Y? So this is an ES6, I think it's called a template string. This doing template strings like this is the same as, so you see I used backticks, and that lets me use variables directly in the string. I could also have done it this way. Brace, okay, here in the const Y, that is called the object destructuring. So this is actually the same as doing it like this. So I prefer using object destructuring because then I can take multiple things out of our props if they were defined in props. Does that answer your question? Perfect. So you're gonna see a lot of this sort of syntax where I default to using object destructuring because it makes it easier to later add more things to my code without having to change a lot of different stuff. So this component by default is rendering just a grouping element, and then in component did mount and in component did update, we make sure to call this.d3 render. Component did mount is a lifecycle that runs every time on every first render of our component. So when React takes our component and puts it in the DOM, mounts it, it calls that function, and then every time our props update or our state changes, or any time that React needs to say, hey, this component now has different values or different data, it calls component did update, which in our case also calls d3 render. Now, can anyone recognize this code that we put inside d3 render? Can you tell me where that code's from? Exactly. Steven is on the right track. This is the exact same code we had in the pure D3 example. So we literally took the D3 code from here and pasted it in our D3 render so that we were able to render our axis. The only difference is that we used, here we called D3 select SVG, appended a grouping element and called axis on that. In the React example, we don't have to append the grouping element because we already rendered it with React itself. But we select the grouping element that we rendered, and we call axis on it so that it renders in there. The idea here is that with this, we literally gave up control of that particular DOM node and gave it to D3 so that D3 can do whatever it wants and render what it needs. And that's also the reason why we have to recall D3 render every time something updates, because it could potentially mean that it needs to render differently. So if we were using any props in here, we would have to re-render every time because we're just not sure if what we're updating is affecting our rendering. So we have to, just to be safe, we have to keep recalling it. Does that make sense? Perfect. So if I was adding a label to the axis, in this example, I would be adding it in axis.js, or rather, generally, I like to, generally I would prefer to keep my axis component as self-contained as possible. So if I consider a label to be a part of my axis, and I want all of my axes in general to have labels, I would do that in axis.js, because that way I can say, hey, just render an axis, and an axis always has a label. So in theory, I try to put as much stuff as possible that is contextually linked together in the same component, or maybe make a component that uses an axis and renders both an axis and a label. Yeah, does that answer your question, Stephen? Okay, perfect. So this is our black box example. Now, you may have noticed that writing component did mount and component did update every time could get pretty tedious if you had to do it over and over again. So another approach I like to use is making a a higher order component that can do this for us. Has anyone heard of higher order components before, or hawks? Great. Ivan has heard of them before. So has Henning. Perfect. So for everybody else, a hawk is essentially it's a React component that returns other React components. You can think of it as like a component factory almost, but the idea is that we take components as arguments and wrap them in more functionality. So I created a D3 black box hawk so that we still render our axes as axis and give it an x and a y, and it renders here. We can move it around a little bit by changing the x or the y property, and the way it's implemented is like this. It imports D3 black box, which is a higher order component, and passes in a function. Now this code probably looks familiar. Who recognizes this code? Okay. I still need to work on my prompts. Yeah, same thing again, anchor looks new. So it's exactly the same D3 code that we had before. We just changed D3 select from this.gref.current to be a slightly more general this.anchor.current. That's because the D3 black box higher order component is defined like this. It's a function that takes a function as an argument, in this case D3 render, and it returns a very similar, it basically returns the same axis component we had before, except now it's called black box and uses slightly more general naming, and does the component did mount and component did update stuff for us, so we don't have to worry about it. It still renders a group. Let me resize this. So it's still rendering a grouping element. It's using a transform to move things to x and y, and the ref is anchor instead of gref, because I find anchor to be a slightly more general term. It's always going to be a grouping element because this is SVG and that's what anchors usually are, but it could in theory be anything. And another difference is that in component did mount and in component did update, we had to use JavaScript's dynamic scoping to convince the D3 render function to run in the same scope as the object we are rendering. Wow, there's a lot of noise out there today. So yeah, that's the D3 black box higher order component that lets you render pretty much any example in pretty much any D3 example in a React context by just wrapping it in this function and then passing in a function that does all of your D3 stuff. So to make sure that you all understand that, we're going to do a little exercise. I'm going to give you, let's say, 10 minutes to play around. You can go to this code sandbox and fork it. So go here, press fork, and then I would like you to take the bar chart example from earlier and making it render inside a React component. So we're going to take this. You can find the code by clicking View Page Source and scrolling down. This is the code you need. And I'm going to give you, let's say, 5 minutes to try solving it on your own, then we're going to solve it together. And if you have any questions, please do ask. Share a link to the chart page. Good point. So the link is also on our materials, but here it is again. and I have the link to the data also prepared. So 5 minutes, then we will do this together. And I will have some food. So Did anyone get it working yet? Is anyone working on it? So one of the problems with these online workshops is that I can't really see what you're doing. So I have no idea if you're just sitting back and waiting for me to solve the problem, or you're actually trying and having some difficulties, or how it's going. Say hi to your kids. And kudos to you for staying on the workshop even though your kids got home. I think one of the most common reasons people say I pre-ordered the book but I didn't come to the workshop is because Sunday is my kids' time. Unhandled rejection error. That's strange. Okay, let's try solving this together. I'm gonna fork it. And let's see what might I do differently than, or we might even run into the same problems and we'll see what happens. So I think I forked it. Let me make sure that I forked it. Alright, now I definitely saw the hash change. So I'm going to create a new file. New file called barchart.js, and we're going to import React from React, and we're going to import d3 blackbox from /d3 blackbox. Wait, they give it a capital? No capital. So d3 blackbox, and we say export default bar chart, and class or const bar chart equals d3 blackbox, which takes a function that is going to do our rendering. I'm going to save this for now and render it here, just to make, this is going to make sure that we are not, what was I gonna say? Just making sure that we are importing things correctly. I like to always first render something that's basically empty. See, import bar chart from /bar chart. Great, now it's blank. That's a good thing. It means we don't have an error in our basic setup. So I'm going to go here, click view source. I'm gonna close this one and copy paste all of this. I believe this is the same thing as Eric did, and we'll see what happens. So rendering the same thing. Oh, I know where we ran into trouble. It's because we're using D3 V5 and the example is still built with V4, so we're gonna have to change one little thing. I'll show you. So first, our SVG is going to have to select this.anchor.current, and here when we're getting the width and height, we're going to hard code these guys for now to 400 and 400. The next thing is that the main thing that changed between D3 V5 and D3 V4, we also have to import D3. Import D3 from D3, and I'm going to say asterisk as D3 because that makes it easier to use. And I believe this is where Eric got stuck. Unhandled rejection error, right? Yeah. So the difference is that in the old days, data loading functions, D3.tsv is a data loading function that makes an AJAX request or maybe a fetch request to a server or to whatever URL and returns that data set parsed as tab separated values. It used to be callback based, but now by default it's promises based. So we have to change this to say then, and we have to take out this error bit here. and we also have to not use errors, and now it's working, but it's not loading the dataset because we have to also change the URL. So I'm gonna go here and copy pasta the link and put it here, and now the bar chart appears. One last thing we can do is we can is also add the styling. So we say style.js, no, not JS, style.css, style.css, and copy paste it from our view source like that, and import it. And now we have our bar chart. To make it a little bit more, to make it easier to use, we can also pass in a width. Let's say we want it to be 300 high, wide, and 200 tall. Where do you think we would use those properties or those props? Line 8 and 9, yeah, exactly. So here we're going to say this props width and this props height, and we now have a bar chart that's relatively easy to use. We can place it around on the screen and even reuse it as a component. Let me show you. We take this bar chart and we render another one that is going to be, let's say, 400 pixels wide and 300 pixels high, and it's going to be rendered at x of 0 and y of the previous one is 400, so 300, and we have to make our SVG much bigger for that to work, and there you are. So that is how you can take literally any D3 example on the internet and very quickly wrap it in a React component that then gives you all of the reusability. You can move it around, paste it around. It's a component. It gives you almost all of the benefits of using React with D3 together. As we saw, when you might have to do some small modifications to the code that you find because it's from different eras of D3, but the differences between V4 and V5 are not actually that big. So the main breaking change that I found is would it be easy to make these charts resize when making the windows smaller and larger? Yes and no. So SVG as such doesn't have any support for responsiveness. What you have to do is you would have to add a global listener of some sort to the window resize. So window on resize event you'd have to listen for, and then change the widths and heights that you're passing in, and your scales will then automatically adjust and make things scale. I haven't found any easier solution than that, but that's something that works. But this so what I was gonna say is that this is a good approach for getting started very quickly, for quickly putting things together. Unfortunately, this starts breaking down once you have a lot of charts, because I would love to see how Ivan had responsive SVGs easily, because that sounds pretty cool. I haven't found there to be a super easy way to do responsive SVGs, but the main problem with remove width and height, well, if you remove, does that so if you remove width and height, but that still doesn't scale your charts that are on the SVG. And anyway, the problem with this black box approach is that once you have a lot of elements on the screen, once there's a lot of changes going on, you are you're going to start running into scalability issues, into performance issues, because you are re-rendering the entire subtree of that component on every little update, which gets expensive and problematic. And I had somebody came to my workshop once who said that they used this black box approach to build a complex dashboard, and they ended up with what was, I think it was, render times in a couple of seconds. So anytime you would try to interact with the graph or try to mouse over something or click on something, it would take a couple of seconds to re-render the entire dashboard, and it made the whole thing basically unusable. And that was why he came to the workshop, was to learn a better way of doing it so that they could improve performance. Still better than Tableau. I have never actually used Tableau, but I have met somebody who worked there once. So that's the D3 black box approach. We're gonna take a does anyone have questions about the D3 black box approach, or does that make sense to everyone? How you can wrap things in, how you can wrap D3 charts in React? Makes sense? Perfect. Then we're going to take a 3-minute break. I'm going to go make some more tea, and then we're going to continue, and we're talking about the full feature integration, and we're going to go through a couple of steps to build a scatter plot component that you can then use to make the final project. All right, we are back. I think that actually took more than 3 minutes, but before we get on to full feature integration, does anyone have any more questions about what we've done so far? Great. Oh, we gained a new participant. That's awesome. Hello, new person. I don't know which one of you it is. So, like I said, the black box approach to React in D3 is great when you're building something quick and dirty, but it's not going to scale to building an entire dashboard or your entire product that's visualization focused, because it's not the best for performance. It leverages D3 a little bit too much. It doesn't really use what React is good at, that almost at all. It does have componentization and some of the benefits from there, but really you're not using React's rendering engine to give you all of the benefits that it could. So we're going to look at full feature integration, where we are in fact going to make sure that we are using D3 just for calculating attributes and just for data manipulation, and we're going to be using React to do the do the rendering itself. So we're going to aim to build our components in such a way that they are always a pure representation of their props. So we want our components to be so-called controlled components, where the consumer, whoever is using our component, can define how it behaves. So whenever it re-renders, it should listen to the props. Whenever the props change, our component should change as well. So we have two different, how should I say? I was gonna say something. So we have two different situations we can find ourselves in. We can be in a situation where we know for a fact that our props are never going to change for whatever business reason that we have, or we think our props might change. So the first version is easier for us to do. The second version means we have to actually make sure that we're consolidating between D3 state and whatever the props changes are telling us to do. So we're going to build a little scatter plot like this. It's going to have a label. Oh, we forgot to do an example earlier. Oh well, it's okay. We did a different one. So we're going to use axes, similar to the components we built before, except these ones have a little more flexibility built in. And we're going to render a scatter plot using the full integration approach. So in the first situation is where we know for a fact that props aren't changing. That means we have to only take 2 steps to do the integration. We have to set up our D3 objects as class properties, or rather as instance properties, and we have to output an SVG in our render component. So we're going to build a little scatter plot where we're going to generate some random data, and then we're going to render a circle for every point in our data set. So I have here a solution from before, but we're going to build a new one together, and I'm going to do it as a live code sandbox share so that we can all participate. And while we're doing this, I'm going to ask you to try to put some code in, or maybe actually, let me ask you, what do you prefer? Do you prefer if we all work together in the same code sandbox using the live sharing feature, or do you prefer to work on your own separately and follow along as we work on this? On your own? Same? Okay, so you can actually do whichever one you want. So either start on your own computer, or work in the what's it called, in Code Sandbox. create code sandbox React is the same as running create React app, is this create React app and giving it a name. So I like doing it in code sandbox because it means I'm not putting a bunch of stuff on my computer. So I am going to do this. I think we have to make a change to make it save. Okay, that forked it, and I'm going to go live. So anyone who wants to join in the same one can do so via that link. We're going to need a dependency for D3. So we add a D3 dependency. This is going to give us all of the stuff that we need to do D3. Now, first thing I'm going to do is create some random data in our index.js. This random data is going to be two-dimensional, so you can either do this on your own if you're working separately, or you can copy paste. But const data, we're going to say, let's say 100 data points. I'm using d3.range, gives me an array that counts from 0 to 100. I can then map over that. I don't care about the argument. And we're going to return a two-dimensional array of two random values. We're going to use, the first one is going to be our x position, and the second one is going to be our y position. And we have to import asterisk as d3 from d3, like that. So we now have our data defined. I'm going to console log it so that we can confirm it worked. And yes, for those of you joining live in the same code sandbox, I think it drops you out when you click out of the browser and click back in, so that's kind of annoying. But if we look at the array down here, you can see that we have 100 elements, and each of those is a random number between 0 and 1. And because of how random distributions work, a lot of them are somewhere in the middle of that. Now, how would you suggest we render this? If you had to guess at a general approach, what would you do? If you wanted to render a data point for every node, for every element in the data array. Map, yes. So we're going to iterate over our data and render a data point for each of them. We're going to create an SVG element first that is going to be 800 by 800 pixels, and this will give us like you can think of this as our playing area where we can draw SVG stuff. Inside there we're going to render a scatter plot, and what I like to do is I like to always make my visualization components in a way that accepts X and Y properties so that I can position them on the screen easier. So we're going to say our scatter plot is going to be at x0 and y0, and it's going to take our data set as data, like that, and we import scatter plot from /scatterplot. And again, I like to have my data visualization components in their own separate files because that way it's easier to navigate in my code base. You can just go to the scatterplot file to look at how the scatterplot works. Scatterplot.js, although in small projects like this, it's not that important. So scatterplot.js has to import React from React, and we're going to need import asterisk as d3 from d3, and we say class scatterplot extends react.component, and it's going to render for now just a grouping element that we are going to translate to the X and Y positions. So grouping element transform equals translate $x and $y. we end that grouping element and we say export default scatter plot, and I have a syntax error up here in my import, so I can fix that. So who can guess what I did wrong here? Or can anyone fix it directly? Okay, it's a JSX syntax thingy where you have to, when you're passing what's it called? When you're passing JavaScript directly into JSX, you have to wrap it in curly braces, and I forgot to do that. And we make sure that X and Y are taken out of our props, and we now have an invisible scatter plot because we haven't rendered anything yet. While we're here, I'm also going to remove these titles because they are unnecessary. So like you guys said, or like Ivan said, we're going to map through our data and render a circle for every data point. So X, Y, and data come from our props, and we say data.map that takes X and Y position from the data, from the entry in the data array, and returns a circle where Cx is X, Cy is Y, and a radius of, let's say, 3 pixels. Cool. Can everyone see the scatter plot? It's up here in the corner. Let me move it down a little bit so we can see it better. Let's move it to 50-50. Now, can anyone guess why the scatter plot looks like only a single circle, even though we definitely rendered 100 of them? And I can actually prove that we rendered 100 of them. If my computer lets me. So I'm going to select this element. Come on, computer, you're behind. So we have our SVG, and you can see there are 100 little circles in our SVG. They don't actually have the same X and Y, but they are very similar. So the problem is that our random values are generated, are random values between 0 and 1, which means that they're all very, very small. So when we render everything, it looks like it's rendering on top of one another. It's moving around by a couple of fractions of a pixel. So what would you suggest we use to fix that? Scales? Yes, exactly. So we're going to create an X scale, which is going to be a linear scale, b3.scale_linear, and it's going to have a domain that goes from what? What's the easiest way to define our domain? We know that the span of our data is from 0 to 1, so our domain is also going to be from 0 to 1, and our range should go from, let's say, how wide do we want the scatter plot to be? Should we say, let's say we want the scatter plot to be 300 pixels wide. And we have to actually use our scale here when we're calculating the X. We say this dot X scale of X. And now our scatter plot looks like a wide line with a little. You can now see that even the little fractions of a pixel are actually moving our circles around. Who feels courageous enough to go implement something similar for the vertical component, for the vertical axis, for the y-axis, and make it use a scale for the CY position? think we have a couple of you who are live in the same one. Yeah. So I guess Ivan or Mike. I think everyone can edit. Yep, perfect. There you go. Awesome. One less step, Mike. Yay! We have a scatter plot. Now, how can we make it so that our scatter plot is so that we can specify the size of our scatter plot from outside? Who can make a guess in the chat room? Almost. So yeah. So it is, Mike is on the right path, but he started off in the wrong spot. We're going to, you can't use let there because you're in the class body. So what you can do is you can say this.props.width for our ranges. I think this is where Mike was going. And you can correct me in the chat room, Mike, if I'm guessing wrong. So we can use this props width and this props height when we're defining our scales. And in index.js, we pass them in as width equals, we said 300 and height was 200, right? Interesting. I'm pretty sure this is supposed to work. Oh, now it does. Oh, was there a typo there? Cool. So now we have again a scatter plot where from the outside we can say make it taller or narrower or whatever. It's great. We can also we can delete these guys because we're not using them. Now the easiest way to add axes to this is we can take my code from before, and this was supposed to be an exercise, but we did a different exercise instead. So let me find it. That one. So here I have a slightly more complex version of the black box axis implementation that gives us a little bit more flexibility. So I'm going to copy paste this into our scatter plot example. So this axis is using where is it? So it's using the ability to set orientation of the axis through a prop, and it's also letting us define the actual scale that the axis uses through props. So I'm going to copy this and I'll show you how it works. This one, yeah. So new file axis.js, we paste that there, and we go to our scatter plot and we import axis from /axis. Now where would we add these? Where would we add an axis? Okay, add start component. If we wanted to render an axis next to our scatter plot, where would that go? Where in this component? And you can either start typing directly in the live shared Code Sandbox, or sound off in the chat room if you can make a guess. Okay, so you can put it in index.js next to scatterplot, but then your heading is on the right path. So let's explain it for Steven. If you put your axes in index.js, that is going to work. They're going to be rendered. But if you want to move your scatter plot somewhere else, or if you want to render multiple scatter plots, you will have your index.js will start exploding, and you will have to deal with more and more stuff. So it's better to make the scatter plot self-contained with axes and put the axes in there, so that the scatter plot itself knows how to render its axis, and then you can move it around and make multiple of them, and you have less code to change when you're moving things around. Exactly, grouping the elements that are part of the same context. So we're gonna go here and say axis, where x is 0 and y equals 0, and we say, I think I named it orientation, let's check, type, and we say type equals left, and scale equals this dot y scale. And we should get an axis rendered on the left here. Yes. And we can give it a label of y, because that makes sense. So now we have an axis that's rendered on the left, and we can copy the same code and put it on vertically. This is at this dot props dot height, or actually let's take it from props here. So see, this is again an example of why I prefer using object deconstruction than doing it piece by piece, because I can easily add more properties here. And we say that it's a bottom scale. And we have to pass in the x scale, and then it's going to work. And label of x. See? And we have a what's it called? We have a scatter plot that has both axes, the left axis and the bottom axis, and the whole thing is rendered wherever we want it. We can even we can copy it and make another one. You'll see, like this, that we say renders at 350, like that. So you see this, putting everything together in the scatterplot component made it easy to move scatter plots around, or to make multiple versions of the same thing that's rendered in multiple places. Does anyone have questions about what we've done so far? Or would anyone venture a recap of how this implementation works, or how this full feature integration works? Yeah, and in the actual, so just like Steven said, you group everything that belongs together in the same component, and that makes it easier to reuse. And the actual D3 and React integration part happened in 2 steps. We defined the X scale and the Y scale based on our input width and height, and we knew the domain in advance, so we don't have to calculate that from our data set. Sometimes you do have to. We define those as instance properties on our thing. That's a bad way of saying it, but instance properties on our component, and we went through our data and rendered a circle for every data point. Is it simple to center the label? I don't think it would be useful to make a ref for each of the points, but what we're going to do in 2 steps, so the next step is going to be making this respond to props changing, and the next step after that we're going to be using render props where we're going to use a separate component for each of the data points. So you'll see how that works. And that will give you the ability. Yes, so Eric, and Stephen, it is actually simple to center the label. You do that right here when here I'm calculating it like this, but you could make it so that it calculates the center of its scale of its. Let me just show you. So if we say 1 divided by 2, now the label is going to be in the center. See? So this is calculating the positioning of the label. Anyway, now to answer Eric's question, because that ties in perfectly to what we're doing next. The next step we have to, the next thing we have to fix in our implementation is that right now our component doesn't update when our props change. So I'm going to tweak our index.js so that the width and height of our scatter plot change based on how many times it's been clicked, and then we're going to see what happens with our rendering when the props change, and after that we're going to fix it. So great question, Eric. Let's see, let's go to our index.js. I'm going to make it so we have, let's have 2 of them. And I'm going to quickly change this into a class-based component, because that will enable us to have some state. We're going to say this renders. Great, so we still have we're still rendering both scatter plots, except now our app is a class-based component, and we're going to define some state that says width is we set 300 and height is 200, and we're going to have an onClick function that's going to call set state. Now, who can tell me what happens after we call this set state on a React component? Yep, it re-renders. So we're going to change them by, let's say, 20%. So every time we call this onClick action, it's going to update state with width and height being smaller by 20%, and we're going to call that function when we click the SVG element, like that. So let's see, when I click on SVG, wait, nothing happened. Okay, so nothing happened. It could be that my onClick handler isn't working and state isn't updating, right? We can verify that. We can console log every time our app component is re-rendering. We can console log our state. Now let's see if my click handler is actually working. Okay, so click handler is working, width and height are changing, but the scatter plots are staying the same, even though they're being passed a new width and height. So who can tell me why that is happening? Or who can guess? Who can venture a guess why that's happening? Yep, the scatter plot component is static, but why is it static? We did use props width and props height when we were defining our scales. So, okay, you guys are on the right path, but you're missing a little detail that's important. So we are passing props into our scatterplot component, although you're right, we're not actually passing them here. So good call, whoever started changing this. We do have to change this to be state width and state height. But you'll see it's not actually going to change what happens. So we're now definitely passing width and height into our scatter plot component. And the only thing that's changing is where the y-axis shows up. So you can see that the re-rendering does run. We can confirm that with the console log and say width and height that we're going to take from props. So width and height come from our props, and we click and they're changing, but it's only moving the horizontal axis. And the reason that happens is that even though we're using this prop's width and this prop's height when we're defining our scales, we're actually doing that not on every update, but only when the component is first instantiated. So we're going to use the new yes, good guess. So component did update is a great guess. The problem with component did update is that it runs after our component already updates, which means we are still going to be rendering stale data. So if we update our D3 after we already re-render the component, that's not going to change how it's rendering until the next cycle. So it's always going to be one cycle behind. Instead, what we can do is use the new get derived state from props lifecycle that came with React 16.3, and I believe is going to be the main way to do something like this going forward with the new React suspense and all of that. So we're going to move our scales into state. The easiest is to wrap them in a state object, fix the syntax like that. So we now have X scale and Y scale are in state. We're going to take them out of state down here so that React stops yelling at us that things are not defined. So X scale and Y scale like that. No, this is still not the full step. We're also going to call get derived state from props, which takes I always forget, is state first or is props first? I think it's props and state. And we're going to say let X scale and Y scale come from state, and we're going to say X scale dot, basically what we're doing now is updating the range of our scales so that they correspond to the new props. So and it's a static, I always forget that part. So static get derived state from props, X scale dot range now goes from 0 to props dot width, and Y scale dot range goes from 0 to props dot height. And we have to return our state. So to make sure that we're not deleting anything from state, we take the old state that was passed in and return it with using the new, I don't actually know what that's called, object spread, and we say X scale and Y scale. Let's see if that works. What happened in axis? Okay, state and props. That is a very strange error to be getting. Oh, that's what we did wrong. So I forgot to update where Y scale and X scale come from when we're passing them into the axis. So we gotta change that as well. Now let's see. Okay, so it does get props and state. There we go. So let's see if this works, and then I'll walk you through again what exactly we did. There, see? It's now becoming smaller whenever we click. So here's what's happening. When our component is first instantialized, this is just before it first renders into the DOM, we define state, we define local component state using we define local component state with x scale and y scale, so that they're both essentially the same code as we had before, except now they're being put into an object, into a state object, instead of directly as instance properties on our component. Then we updated our render methods so that we're using those scales from state instead of from instance properties. And we're using get derived state from props, which is a static lifecycle method that is called anytime React renders our component for any reason. It's not necessarily because our props updated, it's not necessarily because our state updated, could be for whatever reason, which means we have to be a little bit careful what we're doing in here because it could lead to performance issues. But anytime that happens, we derive a new state from our props so that we can make sure our component is fully controlled from the outside. In our case, we knew that the only thing that's changing is the range of our scales, is the range of our scales. So we update them to the new width and to the new height, and then we return the newly calculated state, which, if you've ever used Redux, this pattern is probably familiar to you because it means we're returning a new copy of our state, preserving all the old values and changing the new values. And that's how it works. We now have two scatter plots that are fully controlled from their components that are fully controlled by their props as defined by the consumer component. If you have large sort of calculations here, it's a great idea to use memoization. There's a bunch of memoization helpers out there, but if you have a data set of 50,000 elements and you have to recalculate something based on the data set every time your component renders, that could cause problems. So try to not do it every time. Another good rule of thumb is to try to use pure component instead of just component, because that again reduces the amount of times that get derived state from props gets called, and I can actually show you that. Let's see, console log deriving, and we're going to make it more obvious, I'm going to remove one of the scatter plots here. So let's see, it's deriving once. Now when I click, it's deriving another time. It's actually going to be pretty okay. So React.component is already good enough. Pure component in this case won't give us any benefit, but in general, if you're using get derived state from props, I would recommend doing it with a pure component, where the difference is that React pure component is a little bit smarter about how often it calls your component's update cycles. Now, does anyone have questions about what we did here or how this works? Or how about this? Who finds this surprising? Or was anyone surprised by what we just did to make it work? Reviewing the video will help. Okay. It's a long video. Cool. So now I think Henning asked earlier what we can do if it ever makes sense to have a ref for each data point. So we're going to do something similar. Has anyone heard of render props before? Yep. Okay, so we're going to use render props to give control of what each individual data point is supposed to look like to the outside world. So you can think one buzzword I've heard of describing this is inversion of control. Another one is renderless components. But basically the idea is that we have this working scatter plot that has a bunch of logic, so it knows everything it needs to know to render a scatter plot. but that doesn't mean it has to know how to render a data point. So we're going to add a prop called data point, which is going to define how a data point is rendered, and we want a data point to get an x and y position and render a data point component at x equals x and y equals y, like that. Now we have to define the data point component, which we're going to do here. Import data point from /data point. And we define a new file. Not in public, in source. A new file called datapoint.js that imports React from React, and it's not actually going to need D3, and it's going to be class dataPoint extends react.component render export default data point. And to make our lives easy, for now we're going to copy this scatter plot, this circle here, into data point. So copy, and our data point is going to return the exact same thing. And instead of x scale x, it's going to call just x and y. And those are going to come from props. So const x and y equals this dot props. Cool. Is anyone confused about what the data point component is doing? Nope, perfect. That's what I thought. So here's how we use that component here. We're going to take data point from props, and here where we're calling in our iterator, we're going to, instead of directly rendering a circle, we're going to call the data point function and pass in our x as x scale of x and y as y scale of x of y, like that. So let's see if I can make that a little bit, parse a little, render a little nicer. Cool. So what we changed, we changed it from directly rendering a circle to calling a function with our changed props, whatever they are. We said x scale and y scale, and passing that into the function, which means that our consumer was able to take control over how something is rendered and define it from the outside. So it could be a data point. We could technically have it defined as another scatter plot, but that would be interesting to try. We can try that later. Actually, yeah, we can try that later. Now, and then we have a data point, which now is a full component that takes its positioning from the outside, and it can be made to look prettier. So if we change circle to be a styled component, I think I just crashed this thing. My computer is starting to struggle. So I am no longer able to write into my code sandbox, which is quite unfortunate. Yeah, you're right. It took much longer this time for my computer to start struggling. I think it's because I stopped the recording a couple times in between. So let me try opening this in a new tab. Ah, no, I don't want that. Okay, loading sandbox. Come on, last thing. Going to data point. Close this guy. Okay, and I'm going to say import styled from styled components because I can. and we're going to define a circle component, which is a style circle. And you might be able to hear me typing much faster than things are actually writing out on screen. And you know, maybe it's time to buy a PC, but I don't want a PC. I like my Mac. I don't know. I need to figure something out because these computers are apparently not strong enough to do everything I need them to do at the same time. Oh, no, I want you to wait. What is taking so long? Or maybe we can close some of the sandboxes. Interesting. I wonder why Mike's live code sandbox froze as well. Okay, let's see if it manages to load this time. Okay, looks like it's going to work now. So we have a circle, and we're going to say that it's filled with a light blue color, or let's say steel blue, and fill opacity is going to be 0.8, and let's say its stroke of steel blue and stroke width of 1.5 pixels. So you can now see we have these pretty nice, or rather at least nicer looking data points that are styled. We can make them even nicer like this, and we can also add interactivity to this. Wow, somebody's yelling outside. So an easy way to add some interactivity to our data points would be to add mouse over events that make them bigger or smaller, or change their color or whatever. But that's not really, that's more reacty and has less to do with data visualization. The point I'm trying to make is to show you that once you have this basic integration done, you can use a lot of your existing React knowledge to add and enhance how things work and how they display and how they render. So we're going to take another couple of minute break so I can go replenish my water and you can stretch out, and then we're going to talk about animations using two different ways to animate things. And in the meantime, if you have any questions about what we just did or how this works, please ask in the chat room and I will do my best to answer. And let's see if I can. Let's continue with the question that Mike posed. Why don't we just import data point in our scatterplot component instead of using render props and all this complicated rigmarole with props? So the reason for that is that we can now use the same scatterplot component to render different looking scatterplots. Let's say we want to, let's create another data set called data2. Oops, data2, so we have two random data sets, and we use the exact same scatter plot, render it again down here, let's say at position 250 vertically. We don't make it respond to width and height changes in the props in state, sorry. So we say it's 300 pixels wide and 200 pixels tall always. And this one is instead going to render as black circles. So it's going to have cx of x and cy of y and r of 5. Let's make it like this. R of 5. And there it is. Or we can make it have it a smaller r. So we now have two scatter plots rendering different data, rendering their data points in a different way, so they visually look different as well. But we were able to use the exact same component we already developed to build both of them, and that kind of makes our data visualization components easier to reuse and generally more flexible. Does that answer your question, Mike? Perfect. And I wanted to try something crazy earlier, so I'm going to try it now. If we say data, oh, I actually forgot to pass in different data, but let's say data2 is only 10 data points. What happens if we try to render an entire scatter plot there? So we're going to render a scatter plot on each data point. It's going to use, that's going to give us infinite recursion, isn't it? No, it's not. So we're going to render 10 data point thingy. It's going to be 20 pixels wide and 20 pixels tall. And for its data point, it's going to use a simple circle. So x and y with circle cx equals 1, cx equal, where are you? Cx equals x, cy equals y, and radius equals 1, like that, and we close it off. So we now have a scatter plot that's rendering inside a scatter plot on every data point. And I think it's pretty damn cool that we're able to do that. Can make it a little bit more visible as well. And it's obviously not a great idea if you're trying to do something actually useful, but it shows off how flexible these render props are and just how much you can get out of them. Let's make it 100 pixels. Strangely, the data points aren't rendering, but I promise you, thank you, good catch. Let's see, will it render or will it crash my browser? There we go. See, scatter plots inside scatter plots, because that's something we can do when we have render props. Wonderful. So we're going to move on to the next part of our workshop. If you are curious about things like that, we can. I have a section underneath here that's about server-side rendering. React and D3 charts or visualizations. The idea here is that because we're giving up control of the DOM to React instead of doing it in D3, we can render our entire data visualization on the server and output the actually pre-rendered stuff, which makes it faster to load and all of those other benefits of server-side rendering. We're not going to talk about any of the details here, but if you ever need that, you can come back here and look into what I wrote about it. Now we're going to move on to the animations section, where we're going to talk about two different ways to approach animation when you're using React and D3 together. The first one is one of my favorites because it has a fun name and because I spent a large part of my youth playing with this sort of stuff because I was a pretty boring teenager, let's be honest. I would rather sit at home making little video games for myself in Pascal than go out and play with people. So, but the two approaches to animation are the game loop approach, which gives you a lot of control over what's happening, but also means that you have to spend a lot of time thinking about how to make those things happen. And then there's the transition approach, which means you have a little bit less control, but it frees up your brain cycles to worry about more important things if you decide those things are more important. So the game loop approach is based on the idea that React is really fast and React's rendering engine is also really fast and great at figuring out differences. So instead of worrying about how to animate something, you can change that concern with thinking about how everything has to look at each step of the animation. So in a nutshell, you're re-rendering your stage or your visualization 60 times per second, and because you're changing properties 60 times per second, that means that to the human eye it looks like a nice smooth animation and you're making everything move and look great. It's a concept used in video game design, which is where the idea of game loops comes from, because way back when game developers realized that it takes too much resources to try to figure out how to change something from one state to the next state and how to worry about all of that. It's much easier to just throw it away and re-render it. So that's kind of the approach we're going to be using. Instead of worrying about how to move something across the screen, we're just going to calculate its new position and tell React, you figure it out. And React is going to figure it out because React is great, and it's going to animate something. So the best way I know to show you how that works is through an example. So we're going to build a little bouncing ball, and I'm actually gonna let you, because we've already been together now for just over 3 hours and we've been working with React and with D3. I'm going to show you, talk you through how this example works, and then I'm going to give you some time to try to figure out how to make it happen, because this isn't actually leveraging much of D3. It's mostly leveraging the React side of things, which I believe you're already pretty familiar with, and it's mostly about making a mental shift in how you think about what you're rendering and how animation works. So we have an app component that renders an SVG that contains a bouncing ball component. A bouncing ball component renders a single ball, which is a circle, and that circle is rendered at positions X and Y and has a radius of 5. It's currently invisible because I haven't implemented that part. The bouncing ball component itself has a bunch of comments to guide you through how to implement this. So I'm going to copy paste this here in our chat room, and I'm going to tell you that your job right now is to make sure that you render the bouncing ball component. Let me also import it for you. So import bouncing ball from /bouncing ball, and in the constructor, no, oops, it's not bouncing ball, it's just ball. Okay, so you're going to have to render this in the render method down here. I'm sure you know how to, or you can, it's practice. So The bouncing ball component starts with a default state that puts the ball at vertical position of 5, that's the y, and Vy is supposed to represent the vertical speed of the ball, which can be negative or positive. In component did mount, we start the game loop using a D3 timer, and D3 timers are, you might be more they're very similar to something like set interval or request animation frame and calling request animation frame in a recursive loop. It's essentially a loop that runs roughly 60 times per second and calls our game loop function every time. When the component unmounts, so when we're done rendering it, we make sure to stop the timer so that we don't have background timers running infinitely in the background, because that eats up a lot of resources. And the game loop is currently just console logging high, so you can see this little counter down here speeding, counting very, very quickly all the highs that are being outputted, and I'm not going to click on that because it will crash my browser. So I'm going to give you 5 minutes to implement these 3 commands. You have to render the ball at position Y, and in the game loop you have to change the Y coordinate so that the ball moves with every tick of the animation. So yes, 5 minutes. Click on the link, click fork. I can also make it live. Let me make it live for everyone if you want to do it together in the same code sandbox. I'm going to sit here quietly for 5 minutes, then I'm going to show you how I would do this, and we can talk through why it works. And if you have any questions, please ask. So did anyone try to get that working, or has anyone gotten it working? Yes. You have to, if you want the ball to accelerate, you have to change the velocity in the loop and make sure you render the ball. Yep. Crashes the browser. Okay, let's see. Um, so here's how I would do that. I would render the ball down here in my render method. Let's say x is 10 pixels so that we can see it better, and y comes from this state. Y, like that. So we are now going to have a ball that shows up over there. Perfect. Actually, let's move it a bit more to the right. So we have the ball. In our game loop, we have to update the vertical position and the vertical speed. We take both from state, and we say this set state, if we change y by y plus 1, we're gonna see the ball starts falling down, but it's very linear and kind of slow, and that's pretty annoying. So we instead make it move by vy, which is the vertical speed, and we make sure to always update vertical speed by 0.1. And now you're going to see the ball accelerates down and starts going faster and faster, and eventually it falls off of the visual part of our SVG and vanishes. So we can change that by saying if y plus vy is more than this props max h, then we change vy to become minus vy, and that's going to make the ball bounce back. You'll see. So it now falls down, bounces back up, and eventually reaches the apex of its whatever, the word eludes me right now, but we have a bouncing ball that goes up and down. We can change how strong gravity is and make it fall faster. We could also make it bounce back with a little bit less. So let's say it loses some momentum when it's bouncing, so it goes back at, let's say, it loses 30% of its energy. So now it goes up and falls back down and eventually stops at the bottom. So and it might not actually stop, it might get into a situation where it keeps kind of wobbling down there. So those are all things you can fix eventually, but the idea I wanted to show you here is that the easiest way to achieve animation is to just change your props 60 times per second, and the way human brains work and the way React works is going to come together and create a beautiful animation. But as you probably saw when you were building this game loop part, it's kind of annoying to have to deal with all of that and to have to think about what it actually means to go from one frame to the next frame of your from one frame to the next frame of your animation, how exactly things behave. It's like it very quickly devolves into using a lot of physics to figure out things that should be relatively basic. Mm, but 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 that's the general idea. So does anyone have questions about this particular part? Eric raised his hand. So when the component gets updated, the timer will not be duplicated because we're creating the timer on component did mount, not on component did update. Did mount is only called the first time your component is rendered into the page, not on subsequent times. So this gives you all of the control you might want over your animation. You can do a lot of different things, and from the outside, let me show you, from the outside it actually still looks very declarative. If we make two bouncing balls, let's say we position this one at x 100, x 50, let me just change this. So here we're now going to take this from props. So there's now going to be two bouncing balls with separate timers that have completely independent animation. But from the outside, you don't have to worry about that because we are still in the React world. Everything is still declarative. You just say, I want a bouncing ball. So we can make we can improve our lives and make our jobs. How is the interval determined? What do you mean by interval? Do you mean how often the game loop is called? So the interval is determined internally by D3 timer. It's if it's running in a modern browser, it uses request animation frame. So does window.request animation frame, calls our game loop function, and then recalls itself. So it creates a recursive loop. If it's on an older browser or for whatever reason request animation frame is not available, it uses intervals. So it becomes 1 divided by 60 to run, or 60 times per second. This does get affected by how fast your computer is and by the page going into the background or running out of battery or your CPU being very taxed. It starts making the animation slower, which means to be perfectly correct, you should be adjusting for time. So every time your game loop runs, you should in theory save the timestamp, and then the next time your game loop runs, check that timestamp and see how many virtual frames passed and adjust anything you have to. Yeah, so you would have to add interpolation and have to adjust for time, but all of that is very complicated. So I would suggest you do that with transitions instead, because transitions do a lot of that stuff for you. So if you can get away with using transitions, it's easier to use those. So let's look at how you would use transitions. This was crazy. So transitions are a higher, is higher order the right way to say it, but basically a higher level concept of in animation are transitions, where instead of defining how your objects behave on every little frame of your animation, you can just say, I want this property to change from whatever value it is right now to change to this other value, and I want that change to happen over 5 seconds or over half a second or whatever. So let's look at how that would work. I have another code sandbox here. Do I have a practical exercise? I do. Perfect. So let's look at this one, and I'm going to explain how it works, and then I'm going to give you a little exercise because we are doing pretty well on time today. So the tricky part about using D3 transitions to use transitions in our data visualization is that we're going to combine the first approach of black box integration of React and D3 and our second approach of full integration. So what's going to happen is we're going to use the full integration approach to render our component, but during the transition period, D3 is going to have full control of the DOM. So we're going to both have full control of the DOM in React and full control of the DOM in D3. Ooh. So here's a little example I built. Let me open both files. So we have this little circle, and when you click on it, oh, that's not cool. I messed up my code sandbox. So last week I forgot to fork this sandbox before making changes, so now it is a little bit messed up. Let me fix it real quick. Perfect. Okay, so I have restored this back to the previous state. Yeah, I know. So I forgot to go. Apparently forgot. When I was going through the materials this morning to make sure everything is correct, I missed this part. But the point is, we have this ball component that is just a circle that renders on the left or on the right depending on the state of this Boolean flag. When you click on this, it flips to true, or it flips to false, or back to true. If it's true, we render it on the left, so 15 pixels from the edge. If it's false, we render it on the right, which is 250 pixels from the left edge. The ball component itself is rendering a circle at position X and a right now hard-coded vertical position. It has a reference. This is similarly to what we used in the black box approach. We use React create ref, and then in component did update, I'll show you how the transition works. Now, the first step we had to do to make this transitionable is, let me show you what happens if we render our component directly from props. So it's controlled from the outside, which means it takes the X value from props. So if we don't have a transition and we're rendering directly from props, the ball is very quickly jumping left to right. So we're going to use, we use state as our staging area for props that are changing. So when we get a new prop, instead of immediately re-rendering our component, we instead save that value in state. Rather, when the component is first initialized, we take our X prop and put it in state, and we make sure that our component is rendering from state as well. So we are now rendering X from state instead of from props, which means that if we don't have this component update stuff happening here, it doesn't react to props changing, okay? So it's rendering from state, and state is only defined the first time. Same as what we had happening earlier with our scatter plots. But in component did update, we use D3 select to take control of the DOM node of our circle, and then we start a transition with dot transition. Say it should last 800 milliseconds. Define an easing function. Easing functions are sort of like what we did earlier with our vertical speed. An easing function is a way to do that automatically. So one, a simple one is bounce out, or cubic in out is also a good one that you'll see used a lot. And it basically changes the pattern our ball follows when it's transitioning from one state to the other. With cubic in out, it's accelerating and then decelerating. With bounce out, it bounces when it hits the edge. We say that we want the attribute that we want to transition is the central X position of our circle. And here's a very important part. When our transition is over, on end of transition, we update state of our components so that React is aware of what happened, because React likes to be in full control of the DOM. So when we told React that we are rendering the X position from our state, and then we change that from our with D3, React sometimes gets confused, starts throwing errors. So it's a good idea to, when the transition is over, to actually update state so that React also says, oh, okay, that's where the component is actually being rendered. So that's transitions in a nutshell. Does anyone have questions about this? Perfect. So as an exercise, let me fork this, and I'm going go to this code sandbox, and actually I'm going to make it live as well if you prefer that. So live, and this is the live session. I'm going to give you a couple of minutes, let's say 5 minutes, and try to make the ball transition diagonally across the screen. It's kind of cheating because you already saw me remove that code earlier, but make it so the ball transitions diagonally instead of only horizontally when you click on it. And let's say 5 minutes. And please sound off in the chat room if you have any questions, or if you get it working, or whatever. Just remember, I can't see you, so I don't know what's going on. tweet. Let's see if Ivan, is it Ivan or Ivan?
It's
Cool. Perfect. Let's see if this loads. Yeah, my computer hasn't given up on life yet. Although it is struggling. Cool. Okay, so we have a bunch of completed solutions. Yes. My computer doesn't like running multiple versions of the same sandbox, so I'm not gonna open Eric's. I'm sorry. I'll check it later. So I think you both probably came up with a very similar solution as I would have, at least from what I saw of Ivan's. Basically, in the index we change it. That happened last time as well, where Code Sandbox stops updating which file it's showing. Henning is close. Okay, I'm gonna let's solve it together because we have 14 minutes left, and then we can answer any questions you guys have and wrap up. So let's see. So because I'm lazy, I'm not going to introduce a new boolean like Ivan did. I'm just going to say that come on. Okay, syntax highlighting. It's interesting that syntax highlighting seems to be the most expensive operation. So we say the Y position is also based on ball left, and it goes from, I'm going to be lazy and make it the same as the horizontal positioning. The next thing we change is that we take CY from state, like we had before, and we transition the same here we transition the vertical positioning from props as well as the horizontal positioning, and now yay, it's bouncing diagonally. So this is how you can transition two attributes at the same time. Now here's something cool. You can also make this transition, how should I say, you can sequence transitions. So let's say we want to transition on the horizontal axis, and then we want to transition on the vertical axis with a duration of a much longer duration and a different easing function that says is cubic in out, and then we transition the vertical stuff. So let's see if that works. It should in theory. No. What did I mess up? Transition d3 is cubic in out, this props y, and then we do that. There you go. See? Okay, it's way too slow for, let's make it, instead of being slower, let's make it go faster. So 600 milliseconds. So now it's, why is y so high up? Let's make it go down a little bit more. 20. Okay, so now you click on it, it goes to the right. What did I forget to do? Oh, I know what I forgot to do. I forgot this part. Y props.y. Okay, now it's going to work properly. Yeah. So click, transitions, and then transitions down. Transitions left, then transitions up. And one other thing you may have noticed if you were clicking around quickly is that D3 transitions are smart enough to stop the transition in between if you start a new transition. It literally cancels the previous transition and starts a new one, which solves a lot of very hairy issues you might have with transitions in general, where it's a common problem that people have with this kind of stuff, where they have to wait for the transition to end before starting a new one, which is frustrating to users. But if you use D3 transitions, that is automatically solved for you. It will cancel existing transitions and calculate the new transition based on whatever the current state is, so that it can do it properly. And that's how you can use D3 transitions. The other thing you should keep in mind is that D3 transitions do run in JavaScript, so they are JavaScript based, which means you don't have GPU optimization. They might use a lot of resources, especially on mobile. So if you're trying to transition a lot of elements, like thousands of elements, it's often better to use CSS transitions, because those do in fact get GPU support and run a little faster, use less battery and stuff like that. So any cross-browser issues? Not that I know of. All browsers these days have full SVG support, and D3 is just recalculating stuff in JavaScript and doing interpolations. So as long as your browser has SVG support, it should have full support for everything that D3 does. I guess if you have users who are on Lynx or command line based browsers, it might have problems, but all modern browsers should work fine. See if they have anything else. So that's, yeah, and we're not gonna get into this, but you can use you can build custom transition interpolations so that you can animate pretty much anything you want. And the final thing that I'm gonna leave you with today is a bit of homework, where if you want to practice everything you've learned today, you can take the components you've already built. You've already built the axis component, you've already built scatter plots, you've already made scatter plots using render props. So this is just a question of loading some data. You can start with the starter repo that I have. Okay. So I have a starter repo prepared that already has all the styling, and I think also all the data loading is already there, plus the data sets. And you can use the final solution to build something like this. A dashboard of dog breeds and sizes, where mousing over one of these elements should highlight all the same data points in every, see, it highlights it in every scatter plot that we have on the screen. It's not a super useful data visualization because right, so this is using render props for the actual data points, and then it's using a React context to know which data point is currently selected, so that it can switch state for those data points in all of these guys. It also has a little magic so that when you're resizing your browser, it does this. But I have found that that's a little bit more advanced, but I'm gonna put that in the book. So when you get the finished book, it's going to also talk about responsiveness and relayouting based on browser size. Right now it's just in this example, and I couldn't really find a good way to fit it in the workshop itself, but if you want to learn about responsiveness and that stuff, it's going to be in the book, I promise you. So yeah, that's all I had to show you today. I hope you should now be able to, at the very least, understand enough D3 to be able to take examples you find on the internet, adapt them with understanding of what you're doing. You'll have a good idea of where the separation between React and D3 lies, have some concepts of how to do animations and a couple of different ways of integrating React and D3. So I hope this has been helpful to you. And if you have any questions, I'm going to stick around a little longer and ask away. You're going to get a video of this tomorrow because it takes about 13 hours to process and upload. I would be very happy if when you get the video link tomorrow, you go and answer the type form that's also going to be included with some feedback for me. It helps me improve it. It will help me also make the book itself better. And right now, before you leave, I have one question, which is, what was the most surprising thing you learned today? Because I'm very curious about what people find surprising about this stuff, because that's helpful feedback for me as well. And it really does help. The book is, I'm planning to release it in what was it? The second weekend of December. So these workshops have been partially me developing the material for the book. So now I have to write it out, and it should be ready by beginning of September. Did I say December earlier? I meant you should be getting the first versions in beginning of September. Okay, Stephen is surprised with how quickly it starts making sense. I'm happy it helped to try it a little way, to try a couple times, and you learned faster. Henning says it surprises him how much performance is lost using the D3 black box method. Yeah, that was kind of surprising to me too when I first figured it out. And cheat React state temporarily to use transitions. Yep. Cool. Yeah, and hopefully you now feel empowered to go out and build your own stuff, introduce D3 in your companies or whatever you're doing. My goal here was to make you the people who build libraries and tools for others to use, not just be the ones who take other people's tools and use them. I phrased that weirdly, but I hope you get my point. Cool. So thanks everyone for joining. I hope it was useful and enjoyable, and thank you for coming on a Sunday. I know Sundays are hard for a lot of people, so go enjoy the rest of your Sundays, or I'm sure it's very late in some of your time zones, so have a good night, and I will be in touch. Monday morning 4 a.m. Damn. Sweet. Awesome. Thank you for joining Meringen. I don't know how to pronounce that, but thanks everyone for being here, and I will be in touch via email, and you can find me on Twitter and so on.